women attending meetings like this in 8 different locations. So I'd like to welcome you here to ours at the University of Michigan. So our first speaker is going to be Professor Brad Orr. He's the chair of our physics department, and he's also an Arthur Thurnau professor. This is an honor that's bestowed on our best teachers here at the university, and he's doing great things to revolutionize, bring technology to the physics classroom. So with that, I welcome Brad.
Thank you. I want to welcome you to Michigan. I know that for some of you that are coming from the South, this may be a shock to your system, and I welcome you. Those of you that are coming from Minnesota, you're here for spring. So it's great to have everyone here. If you haven't logged on, if you can try to log on to learninganalytics.com, and then the session ID number is written here. Later on in the talk, I'll try to bring some technology to this. We'll see how successful we are. We always have a risk when we do that. So this is what Michigan looks like under better circumstances, maybe about 6 months from now. It's a beautiful campus. We have 40,000 students. It's a Big Ten school. In our physics department, we have 150 graduate students. We have about 50 majors a year, of which approximately 15 are women. Might get better than that. One of the reasons we're having you all here is we'd like to consider that you might think of us in the near future. So please do. I have to give you an early history of Michigan. Michigan has been a factor in physics since this country really came about and the Midwest was starting to be settled. In the early 1900s, we were a world leader in spectroscopy. Infrared spectroscopy, X-ray spectroscopy. What was being discovered at the early stages of the 19th century was the structure of the atom. And so when you shine light onto an atom, you look at what comes back off, it was quantized. We had to explain that. You needed the measurements. You needed to figure out what were these levels. So this was done here largely because of a technological innovation that we could do very, very well. We could make the diffraction gratings in our shop. So technology has been playing a role in physics and advancing physics for a very long time. It isn't just today with computers. Michigan was a world leader in their shops at this time and allowed us to be a world leader in a particular subject in physics. Later on, in the 30s, it wasn't a technological innovation, it was an intellectual innovation. It was having the leading physicists of the day come during summer for a summer school, gather in the building that you visited yesterday, if you were here a little bit earlier, and talk about what was quantum mechanics. How could we discuss and describe those quantized lines that they were measuring in the very spectra? I list up here some of the names of people that were here, and if you're far enough along in your physics career, you'll recognize them. Fermi, Ehrenfest, Randall, Goldpark, Mayer, Onsager, Gallatin, Laporte. These are really heavy hitters in the development of modern physics. Ulrich, Dirac, Ruan, Podolsky, Compton, Bohr, Sommerfeld, Oppenheimer, Rabi, Lamb. You can't have a physics career without these people being enormously respected. How many of those people are women? How many people say 0? And you can raise your hand. How many people say 1? How many people say 2? The ones have it, the ones are right. Maria Galper, right? Her story is legend. She got her PhD, went with her husband, Mayer, right? So it's Goldberg Mayer, and couldn't, in 4 positions, in 4 institutions, had to volunteer to do work because no one would pay her. When she finally won a Nobel Prize, she had her first offer for a faculty position. I assume it was a tenured position, but I actually didn't know. So in those days, women were very few and far between, and they had to work extremely hard to be treated on any sort. They weren't treated on a level playing field. Okay? As we go on later, the development of the bubble chamber. So we learned how to create very high potentials to accelerate particles to very high energies. We wanted to smash them into other things to understand the inner constituents, and you needed a detector. So, apocryphally, the story is that Don Glaser was sitting at a bar. He was looking at his beer, and there were these bubbles in his beer, and he knows that if particles were to stream through his beer, they would nucleate these bubbles, and thus the bubble chamber was formed. Now, Don says that this story is not completely true. However, it was over many beers that the design was refined. So they did play a role. In the later 1950s, the foundation for fiber optic telecommunication was made here. An undergraduate student Curtis, was in a lab and wanted to trap light in an optical fiber which he could then bend around to other places. The initial use of this was for looking inside the body for medical applications. So it's the future of endoscopy, how you look in without making large incisions, opening people up. So he persisted and persisted and persisted and finally developed a waveguide which laid the foundation, a glass-clad waveguide, which laid the foundation for telecommunication and modern medicine. So this is the early history of what's going on in Michigan, and there are many more things. I haven't even talked about Ullenbeck and Gauchbeck, about a spin here and such. But I want to jump ahead a number of years. I've been here 27 years. I've had approximately 25 graduate students under my tutelage. 5 of them have been women. I want to just mention 2 of their stories. The first graduate student came to me despondent. She had just been told by her advisor that she didn't have the right stuff. She wasn't going to make it in the field that she had tried and strived to go into for well more than a decade, as long as you could really figure out what field of physics you want to go in. She was looking to quit physics. She was looking to go do something else. I said, no, I can use you in my group. I have something that can use your analytic skills. I have something that can use your numerical skills. She did more than that. She did experiments. She did numerical modeling. She did analytic calculations of it. And 3 years later, she won the award for the best PhD thesis in the department. She's now working in a large medical firm in Europe, happy, really glad she stuck it out through these tough times. It is tough. It's tough for everyone. Women have a certain set of difficulties that men don't have, and I hope this conference will get a chance to talk about those so that both you are aware of them, that we are aware of them. I don't like the you and we being set up. We as a community can just make a better environment for everyone. The other graduate student I want to talk to you about, she came to me also. It was in her 5th year and there was no PhD in sight. It just wasn't going well. She was thinking about just taking a master's and stopping. I said, look, we've got a very interesting project here. Let's just switch a little bit. She took data. In her 7th year, she graduated. The paper that she produced and was her thesis now has more than 400 citations to it. 400 citations is being on the New York Times bestseller list of physics. She went to Lawrence Livermore National Lab. She's been there her entire career, which is probably close to 22, 23 years. She's won awards. She's a manager of a scientific group. Been tremendously successful. She had to stick it out for 7 years in graduate school, which is longer than we like, but she did, and she was very successful. I have these sorts of stories, men and women, throughout my entire career. Perseverance is an enormous part of being successful in physics. You aren't born to be a physicist. There isn't some innate thing that just makes it. We are not all the Einsteins or Madame Curies. We are not. It's hard work. This very semester, I had a student, young woman, sent me an email after a quiz saying, Professor Orr, I think I just got a 0 on the quiz. Can I still pass the class? Turns out she had a 1. She had a 1 on the quiz. She got a 7. And I said, of course you can still pass the course. Everyone is allowed to have a bad day. She ended up with an A in the course. She had a bad day. This topic wasn't hers at this point in time. I've had bad weeks. I've had bad years. You just have to plow through it. You just have to stick through it. You don't think it's something wrong with you. Okay? Just keep working on it. All right. So when doing this, one has to go back and see the pictures. This is Don Glaser standing and looking at his bubble chamber. So this is where the liquid would be that formed the bubble. Here's a camera at it. Just a man. Here's one of these summer schools. There's Gauchbeck, Ullenbeck, the discoverers of electron spin, Fermi. And there is Jenny Rosenthal Bramley. If you go to Wikipedia, you'll actually find her being listed as the very first woman PhD from an American institution. This is wrong. She is somewhere around 25, actually. She's got her PhD, I think, 1929. I'll tell you about someone else here at Michigan that got her PhD a little bit earlier than that. I don't know who was the first woman PhD at an American institution. I do know who was the first African-American woman PhD. You have a button with her name on it, Willie Hobbs Moore. And that was, I think, 1954. You can look on your button and see it for sure. So when I was looking at this picture, I was reminded, I saw this picture this very week. And you may be thinking, where is he going with this? Do you know what this is? This was a march in Paris, a solidarity against terrorism. And it was a picture that showed a whole lot of men and a few women, all very distinguished. And what bothered me a lot when I saw this picture was I also saw this picture. This is the same event. What's different? There are no women. Angela Merkel has been photoshopped out. The first woman chancellor of Germany is gone. The mayor of Paris has been chopped off. I'll go back and let you take a look at this. This is this week. And here's the mayor of Paris is over here. Here's Angela Merkel. They just took her out. You know, physics has had a way of taking out the women in physics now a little bit. And I don't know if it was as conscious as this, but this is remarkable. This is remarkable because they removed the Chancellor of Germany. Even worse, Angela Merkel is a PhD in physics. I don't know whether they knew that or not. So we're even more insulted about it. This conference is a little bit like this. We want to highlight the women in physics. All right, so here's one of these photos from the lawn. This is either the Arboretum, which you won't visit to, or out on the dike. I'm not exactly sure. Here's Maria Gelfert-Meyer, and here's her husband, Meyer. And Onsager went on to win the Nobel Prize. Ernfest is known for the Ernfest relations. Atkins is also a very distinguished physicist, but just didn't have, he was a little bit older and worked in spectroscopy and such. So I've already told you the Gelfert-Meyer story, so I won't go through that again. But if we look hard enough, we can see there are, on stamps, we're trying to make sure that the women in physics who were there in small numbers, but have done very, very distinguished things, are in fact recognized. And it's very important for you to realize that there have all along, there have been women making huge discoveries and very important discoveries. I mentioned Madame Curie. Madame Curie has 2 Nobel Prizes. There are only 6 people in the world that have 2 Nobel Prizes. She's the only one that has 2 Nobel Prizes in science in different fields. One in physics, one in chemistry. She's the only one. Okay, so our first female PhD was Catherine Chamberlain in 1924. So that's why we know that the woman I went to before Rosalind is not. So she's very close to the first. I can't claim exactly the first. But she was a pioneer in X-ray spectroscopy. So I said we were very good in X-ray spectroscopy. And she pushed the field. So her thesis was on changes in the oxidative states of atoms when bombarded with X-rays. Sounds pretty esoteric, but actually many of you will experience it in your everyday life. So if later in life you go and get a mammogram, you will be covered with a lead apron. That is because X-rays can change the oxidative state in your body tissue and cause free radicals and cause cancer. And why you and I, when we get X-rays, will be covered with lead. That's her thesis. It's darn important. Continues to today to be very, very, very important. She was an excellent teacher. She was concerned about spreading physics to broad audiences, to people who weren't going to be physics majors. She used photography, which is a lifelong hobby of hers. She said the physics of photography. And she broadcast to a wide range of students why science affected their everyday life. And she used photography as a vehicle. We're doing these sorts of things today. I was just struck by how much of this actually was modern when we're almost 100 years ago. Okay? She was acting in improving the educational experience of women at Michigan. Well, this conference is all about that, not just Michigan, of course. Okay? She also worked for peaceful uses of nuclear energy later in her career after Manhattan Project and against nuclear proliferation. So she was doing many of the same things you might see yourselves doing. She was doing 100 years earlier. She was rewarded and acknowledged for her PhD thesis by a very prestigious prize in 1925, the Ellen Richard Prize. At that time, it was for the single most important publication by a woman in science. Curie had won it a few years earlier. All right? Carried a $1,000 award, which back then was big money. All right? This is a picture of her in 1920. Okay, so we're going to try to have a little fun here. So if I can get this switch. So that ends this part of the presentation where I've done a lot of talking. Now I want you to talk to me. How much time do we have? I'm not even watching the clock. 5 minutes? Okay. I'll take what you give. So, let's hope that this works. So I need to deliver this question. So I'm not happy about that note. But you should now have a question delivered to you. Yes? And there are 86 people have logged on, so that's a very good sign. I have one response, which is a great sign. And I have oh, excellent. It's working. Now, if we have 86 different responses, this won't be interesting. It'll be 86 words. But if there's some common themes, see, you're not supposed to see this. Don't look at this. Newton. A lot of freshmen in here, physics is Newton. Great. Curiosity. So, fun. Good. Maybe I should something else. I'm refining my technique. Let's see, 42. You still got 40 people that can respond. Don't look up here. This is just a warm-up. Life. Okay. So science, okay, is sort of winning. I think I like excitement, fun. Newton is really lost here. Newton was okay. Okay. Well, I saw quantum there. All right, now, so you have to promise, since I don't know how to work this, to stop the delivery. But I want to deliver the next one. Okay, what do you think when you hear women in physics? All right, now I'm going to deliver it. Don't look up here. Don't look up here. You do that? Okay, so we have to have a pretty good response. Let's see. Now the 92 students registered, that's good, and 73 have responded. 75. Okay, so minority. That's the winner. Curie, I hope I seeded that with you here. Rare, few, scarce. Rosalind, determination. I like that. Okay? Smart. Very good. Power. There are only two more. What comes to mind when careers are mentioned? So when you say career, what's mentioned? What do you think when careers are mentioned? Because this is a topic in this conference, and so maybe some of these words will actually end up being appeared in other people's presentations. Oh, I like some of these answers. Okay, now scary. That's right. It is scary. We have teaching and research. Those are two, career paths. It's fear, stress, yeah. NASA, some people want to go into NASA labs. Professor, like prominent. It's not a bad career, but you might have a certain. All right, last question. So now I want to stop delivery and go to 4 and deliver. Who is your physics hero? So I expected this answer the way I had given my talk. Maybe before Einstein, if I went out onto the diag and asked people, who is your physics hero, many people would say Einstein, and I think there's really good reason for that. I like some of these. I saw my dog in here. Dad. Tyson, very popular physicist. Degrassi, okay. Let's see. Tesla, someone who understands E&M. Franklin, not sure what that's for. Roslin, all right. Okay, well, Christine Adala, you were here for a while.
Could have been my sister.
So again, I want to welcome you to Michigan. I also want to give a word of thanks to our CUWiP organization, Society of Women in Physics, who have done an enormous amount of work to bring this conference off. Can we give them a round of applause? There have also been a number of faculty involved with this, and I think Jennifer Ogilvie may have been carrying the bulk of it. I also like to give her a round of applause too. Several of our faculty, Michigan faculty, are giving talks. You'll hear from people from other institutions giving a talk. They've all worked very hard to put this together. So I hope you have a great weekend of discussing physics in Michigan. Thank you.